Question 6, we're told the diagram, obviously not on the next page, underneath here in blue, shows two particles of masses 20 kilos and 13 kilos connected by means of this light inextensible string passing over a smooth pulley. The angles with the horizontal are given by tan A is equal to this and tan B is equal to this. Straight away, tan A is opposite O over A, 4 over 3, so hypotenuse 5. So cos A adjacent over hypotenuse and sine A opposite over hypotenuse. Second triangle, we have tan B is opposite over adjacent, hypotenuse is 13, so cos B is equal to 12 over 13 and sine B is equal to 5 over 13. Let's keep these in mind when we go down and resolve our forces. So 20, let's look at 20 first. We're going to say 20 is going to go down in this way. So I've got my string going back, my T, I've got my 20 G coming down, I've got my OR. We initially smooth, but then we're going to have rough, so I'm going to put mu OR in. Mu OR, and I'm going to put in my angle A here, and just put in my forces. So put an OR there. I'm going to have 20G cos A, it's adjacent to A, 20G cos A, don't rush it, write it out first and then go up to cos A. 20G by 3 over 5, so we're going to have 60G over 5, 60G over 5, which is equal to 12G in this direction. 20G sine A, which is equal to 20G by 4 over 5, which is 80G over 5, which is equal to 16G. And now we know it's going down, we said with acceleration A. So if I create my equation, the only thing going down is this guy here, which is 16G. And going backwards, we have minus T because there's no mu or presently, and that's equal to MA, which is 20A. First equation. So we look at 13 kilogram mass. We have my string. We call the first one OR, we call this OR1. It's going to be going up the plane, so mu OR is going to be resisting that motion. We have 13G, and in this direction we have my angle B here and here. So in this direction adjacent to B, I have 13G cos B, which is equal to, cos B was 12 over 13, so 13G by 12 over 13 is going to be 12G. And in this direction here, I have 13G sine B, which is equal to the sine of B was 5 over 13, so the 13 is cancelled, so we're going to get 5G. So my equation, it's going in this direction, so we're going to say T, that's an 8, let's say T minus, the only thing going down the slope is this 5G is equal to MA, which is 13A. So if I bring my other equation down, 16G, and I have a minus T from here is equal to 28. Combining these equations, I'm going to get 11G is equal to 33A, So A is equal to G over 3 meters per second squared. And then if the surfaces are rough, having coefficient a quarter. So our equations will change slightly. Let's see how. We do it in a different color. So for my 20, mu r is in the same direction as t, so I'm going to have to work out mu r. R is equal to, what's going down this way? 12g. We're told mu is a quarter over here. So mu r is equal to a quarter of 12g. You can just write 3g here, so we're going to have 16g minus t minus 3g is equal to 28, or 13g minus t is equal to 28. So there's less pulling force. And then down here, for my 13g, mu r is in the opposite direction to t. I have r1 is equal to, what's going down here, 12g. So mu r1 is equal to 3g also. So this equation is going to become t minus the new mu r, 3g, minus the 5g we were taking away before, is equal to ma, which is 13a. So t minus 8g is equal to 13a. Let's see how that affects things. If I bring that minus 8g plus t up equals 13a, I'm going to get 5g is equal to 33a. So a is equal to 5g over 33 meters per second squared. And what were we asked? We're asked for the accelerations and the tension. I didn't get the tension the first time round. Let me get the tension in the string. We got a to be g over 3. The tension the first time round, but I can use this one is here beside me. T is equal to 13a plus 5g. T is equal to 13 times a, which is 13g over 3. And as thirds, that will be 15g over 3. 28g over 3. That's in the first instance. The second instance, a is 5g over 33. And if I put that in here, I'm going to get t is equal to 13a plus 8g. 13 times 5g over 33 plus 8g. So the tension is going to be 65g over 33 plus, well, 833 is 240 and 24, 264g over 33. So the tension is going to be 329g over 33. That looks a bit funny. Okay, that's what we've got. It looks like we've no mistakes there if we check back over our work.